Hi, so I've looked at the assessments that some of you have been doing on the Safe Medicate site, and there seems to be one kind of calculation that's catching quite a lot of you out and that you definitely do need to know about. These are calculations that contain an embedded unit conversion. For example, when the prescribed amount is given in milligrams, but the medicine available to you is given in grams, or the other way around. So the prescribed amount is given in grams, but the medicine is given in milligrams. I'm going to cover two things in this screencast. Firstly, I'm going to recommend a metacognitive strategy that you can use on the exam day to stop yourself getting caught out with these. And secondly, I'm going to solve a couple of embedded conversion problems so that you can see exactly how it's done. I've talked about metacognition and metacognitive strategies a lot during our taught sessions. A very basic explanation is that becoming metacognitive involves getting to know how your own brain works and putting tricks and methods in place to help it along the way. For example, if you regularly write things down so that you don't forget about them, that's a very basic metacognitive strategy. They really do work. For example, if you know that you're likely to miss an embedded conversion calculation in the exam, due to either nerves on the day or feeling stressed out about the exam situation, then here's what I'd do. Read all the questions through carefully first. Look really closely for the ones with different units and maybe put a ring around the number or a star next to them so you know exactly where they are. You can then decide whether you want to tackle them first to get them out of the way. Perhaps look out for them as you're going along, making sure that your circled number or your star means that you won't forget that they're there. Or leave them until the very end and tackle them when you're quite happy that everything else is correct. You'll know best which method is likely to work for you, but I do recommend making sure that you've got a method. Okay, let's work through a couple of examples. Our patient needs 0.25 grams of an antibiotic medicine. We have a liquid medicine that contains 125 milligrams in a stock or supply of 5 millilitres. How much medicine do we want to give the patient? Our first step is simply to look at these two units for the medication. Our need number is in grams and our have number is in milligrams. These are different, so we know that we need to perform a unit conversion. Most textbooks recommend that you always convert into the smaller units, and this is exactly what we're going to do here. We need to convert 0.25 grams into milligrams. Milligrams are smaller than grams by a factor of 1,000. This means that we need a much greater quantity of milligrams to equal a quantity of grams. We need to end up with a much bigger number. This means that we need to multiply 0.25 by 1,000. Here's how we do this using the method that involves moving the decimal point. Firstly, we write out our 0.25 grams. I always like to add a couple of trailing zeros to either end first so that I don't have to think too hard about putting them in later on. Remember that trailing zeros theoretically exist into infinity in both directions. It's just not good practice to write them down because in the clinical setting they could cause confusion and result in an overdose or danger to the patient. The next thing we've got to do is to work out which way we want to move the decimal point. As you can see, if I start to move it to the left, I end up with a smaller number. I've now got 0.025, which doesn't look quite right in terms of measuring out medicine. That would be a really, really small quantity to be giving someone. So that's a fairly good clue that that's not right. So let's take that away. And from that, we can work out that in order to multiply by 1,000, we need to start shifting our decimal point to the right. Okay, so if I move it one space to the right, I've multiplied by 10. If I move that decimal point 2 spaces, I will have multiplied by 100. And if I move it 3 spaces, I will have multiplied it by the magic number of 1,000, which is what we want to do. As you can see, the decimal points ended up between a couple of those trailing zeros that we added at the start. That's fine, we just need to tidy up our answer by removing those trailing zeros. Don't forget the zero that's now in our units column, so one space to the left of the decimal point, is no longer a trailing zero. It's become a placeholder zero, indicating that we have 0 units, 5 tens and 2 hundreds in our new number. Our required quantity is therefore 250 milligrams. From here, we've now got a nice basic drug calculation to solve. Our patient needs 250 milligrams. And we have 125 milligrams in 5 millilitres. As we discussed in some of the sessions, there's more than one way of solving that, and we're going to look at 2 ways now. Firstly, we could use a method that involves proportional reasoning, which is just a fancy word for noticing the relationships between the numbers. You might be able to see that 250 milligrams is simply twice as much as 125 milligrams. So if we give 2 lots of the 5 ml unit dose, we will have given our patient 250 milligrams, and we would have done that by giving them 10 mils, which is our answer. And don't forget, we must have the correct unit on the day of the exam. Alternatively, we can use our NHS formula method, which looks like this. We need 250 milligrams. We have 125 milligrams, and that's contained in a supply of 5 mils, which we put over 1 for the purposes of solving the equation. Our first step is to cancel down the left-hand side of the equation, or 250 over 125. So we're looking for a number that goes into both 250 and 125. The most obvious one there that I can see would be 25. So if I count up how many 25s go into 125 first of all, I'm just simply going to count it up on my fingers. 25, 50, 75, 100, 125, which gives me 5. I can use common sense actually to work out that if 250 is double 125, then I must have 10 25s in 250. I can also do that by looking at the fact that we have a 25 there with a 0 on the end, which indicates that that number is 10 times 25. So we now have 10 over 5. Again, both of those numbers are divisible by 5, so I'm going to cancel again. 10 divided by 5 is 2, and 5 divided by 5 is 1. So I've now got 2 over 1, which is the simplest form of saying 250 over 125. I've now got to multiply that by my 5 over 1. If you remember to multiply fractions, we first of all multiply across the top and put our answer there. 2 times 5 is 10. We must also remember to multiply across the bottom, and this is why our over 1 at the end is really important. 1 times 1 is 1. We've now got 10 over 1. That's really saying 10 over 1 is the same as 10 divided by 1, which equals 10. And for the purposes of an exam answer, that must be 10 millilitres. Okay, let's have a look at a slightly different time. A patient needs 600 milligrams of an injectable drug. We have 1 gram, which is contained in 1 millilitre of liquid. How much are you going to draw up for injection? This time the prescription, the need quantity, is given in the smaller unit, milligrams, and the medicine in the larger unit, grams. Following the standard textbook advice, we could convert both numbers to the smaller unit, which in this case is milligrams. Hopefully, you already know that 1 gram is equal to 1,000 milligrams, so I won't go through moving the decimal point this time. This time I'm going to go through the NHS 1 method first, as it contains a final division step to convert your answer to the injectable decimal fraction that you need. To clear up what I mean by that, hopefully you can already see that your answer is going to be a number smaller than 1, that is a decimal fraction, because the prescribed quantity of 600 milligrams is smaller than the unit dose quantity contained in 1 millilitre, 1 gram, which equals 1000 milligrams. So our answer is definitely going to be a fraction smaller than 1. Okay, this one through. We need 600 milligrams. We have 1000 milligrams, and that's in a quantity of 1 over 1. We need to cancel down this side first. We can see that 100 goes into both 600 and 1000, and 100 goes into 600 6 times and 1000 10 times. We have 2 even numbers there, so that means we can keep cancelling. 2 goes into 6 3 times, and into 10 5 times. So 3 over 5 is the simplest way of representing 600 over 1000. If we multiply that by 1 over 1, our answer won't change. So we're looking here at 3/5. Technically, that is a correct answer, but if you remember, the question asked you, how much do you draw up for injection? The answer 3/5 isn't a lot of use to you because you won't find any syringe anywhere that contains fractions or 3/5. We need an answer that you would actually be able to draw up on a syringe. So we have to convert 3/5 into a decimal. If you remember from the taught sessions, this line here simply means divide. If we look at the divide symbol, we can see that the dots simply represent numbers as though they were in a fraction. So we're talking there about saying what is 3 divided by 5. We can solve that by using what I call our bus shelter method, which means that we draw a bus shelter like that, and then we look at our number sentence and we have to simply reverse the order in which the numbers appear. So our 5 goes outside the bus shelter and our 3 goes inside. Before I start working this through, I'm going to put a decimal point in there and a couple of trailing zeros just to make it easier to work through. So the first thing I need to ask myself, I'm just going to go into a different colour there, is how many times does 5 go into 3? Well, it doesn't, so the answer there is 0. I need to remember to carry up my decimal point in exactly the same place. And then I need to carry my 3 over to the next column, so I can either write it up there in the space-saving method. I know sometimes people like to carry them down as well. Whichever method you're used to, stick with that. I'm now going to ask myself how many times does 5 go into 30, which is what I've ended up with here. 5 goes into 30 exactly 6 times. And because it's gone exactly, we don't need to worry about any further trailing zeros, and our answer is 0.6 mils. And again, don't forget to add the unit on the end. There is another way to work this out, and we'll have a quick look at that. We can also convert the prescribed quantity into the same unit as the dispensed medicine. Because our unit dose is just 1 millilitre, this should take us directly to our final answer with no further stages needed in between. This time we're converting from a smaller unit, milligrams, into a larger unit, grams. We need to end up with a smaller number, so we need to divide by 1000, and we do this by moving the decimal point 3 spaces to the left. So if I write my number 600 milligrams, which I'm going to convert into grams, my decimal point starts off here. It always starts off just to the right of the units column there. And again, if we want to, we can put a couple of trailing zeros on the end so we can see how we're working here. So let's start by moving it 1 space. By doing that, we've divided by 10. If we moved it there, we would have divided it by 100, but what we actually want to do is to divide it by 1000. So our decimal point ends up there, in between a 0 and a 6. Again, we need to tidy up our trailing zeros. We don't need any trailing zeros, which is what these have all become, and it's what this 0 has become. Remember, when we're talking about decimal fractions, for clinical practice, you must always put in 1 0 before the decimal point if you're dealing with a number that's less than 1. To fail to do so is leaving what's called a naked decimal point, and those are very, very dangerous in practice. Fatal errors have occurred. So to tidy up that answer, we must have our 0, we must have our decimal point, and we must have our 6, which gives us our answer of 0.6 millilitres. I hope this helps with your revision. Do watch out for these in your next Safe Medicate assessment and also in the final exam. Try to make sure that you've got a method that means you won't forget to check for embedded conversions before starting to work through the exam paper. If you're still feeling confused, please do email me and we'll definitely find a time to go through conversions on a one-to-one basis. Good luck!